These are some rules to remember when you're graphing logarithms. So this is your basic equation for a log. And when you first are graphing logs, you always want to graph your parent function first. And your vertical asymptote is x equals h. Your x-intercept is 1, 0. And you'll always have the point B1. When h is negative, it moves the parent function and the vertical asymptote to the right. When h is positive, it moves the parent function and the vertical asymptote to the left. When k is negative, it moves just the parent function down. And when k is positive, it moves the parent function up. We're going to graph log base 2 of x, and so you start off by graphing your vertical asymptote, which is at x equals 0. Then you want to do your x-intercept, which is going to be at 1, 0. And then after you plot that point, you want to plot the point which is B1. So your B is 2, so your point would be 2, 1. And there you have it. You have your first basic log graph. Now we've added an h, and so we have log base 2 in parentheses x minus 1. So your parent function is log base 2, so you do your basic parent function steps that you did in the graph before. So when you do that, you want to draw a dotted line, and since inside the parentheses it is x minus 1, it moves your graph 1 to the right. And then there you have it, and it also moves your vertical asymptote 1 to the right. Now this one, the same parent function, log base 2, but instead of minus 1, it is plus 1. So you do your basic parent function steps, and when it is a positive for the h, it moves your graph 1 to the left and your vertical asymptote. So this one we're adding a k in, so it is log base 2 in parentheses x minus 1 plus 2. So you start out with your basic steps of graphing your parent function. But now we are going to add in with a k, but first you need to, since it is minus 1 in the parentheses, it moves 1 to the right. And since it's plus 2, you move it, the whole graph up 2. This graph you have log base 2 in parentheses x plus 1 outside minus 2. So you do your basic parent function steps. So then, since inside the parentheses it is plus 1, it moves your graph and your vertical asymptote to the left 1, and since the k is a negative 2, it moves your graph down 2. So this is the equation for finding decibels when you're given the sound intensity. So the equation is D equals 10 log base 10 intensity over intensity threshold. So you're given the sound intensity of 5,000. So you plug in 5,000 for the intensity. And in intensity and intensity threshold, the units cancel out. So when you plug it into your calculator, it is 10 log 5,000, and then you get 36.99 decibels. Now you're given 3,000 for the sound intensity, same steps as last time, and you get the decibels of 34.77. Now its sound intensity is 4,000, and you get 36.02 decibels. Now sound intensity is 6,000, and you get 37.78 decibels. Now 8,000 for the sound intensity, and you get 39.03 decibels. Now 10,000, and you get 40 decibels. Now I put all of the sound intensities and decibels I found from them into a chart, and I plug them onto my graph where the y-axis is the decibels and the x-axis is the sound intensity. Just plugging in the points, and as you may notice that the equation we were given isn't like the same because there are no translations, but the shape of the graph comes out exactly as the same as we were taught in the beginning of the video. And there you have it.